From the Great Wall stretching across the northern plains to the terraced fields of the south, China was a civilization deeply connected to the rhythms of nature and the cosmos. The Chinese have a long history of observing the heavens, believing that the movements of celestial bodies held the secrets to understanding the natural world and guiding their society. The rich cultural heritage of ancient China is intertwined with their advancements in astronomy. For the Chinese, the sky was a canvas painted with the will of the gods and ancestors. They saw the cosmos as a harmonious reflection of the earthly realm, and by studying the stars, they sought to align themselves with the divine order. Astronomy in ancient China wasn't just an academic pursuit, it was a vital part of governance and daily life. The emperor, often referred to as the son of heaven, was seen as the link between the celestial and earthly realms. Maintaining harmony between these two worlds was essential for ensuring peace and prosperity. To do this, the Chinese developed an intricate system of celestial observation to predict events and guide decision-making. Celestial observations played a crucial role in Chinese history, helping to shape the agricultural calendar, which in turn influenced crop planting and harvesting. By accurately predicting the seasons, ancient Chinese astronomers ensured that their society could thrive and avoid devastating effects of poor planning. The development of sophisticated calendar systems such as the lunisolar calendar was one of their remarkable achievements. This calendar combined lunar months with solar years, ensuring that festivals and agricultural activities remained synchronized with the natural world. In addition to its practical applications, astronomy had a deep spiritual and symbolic significance in Chinese culture. The Chinese divided the sky into specific regions associated with mythological creatures and deities. For example, the sky was divided into 4 quadrants, each represented by a celestial animal: the azure dragon of the east, the black tortoise of the north, the white tiger of the west, and the vermilion bird of the south. This division not only helped in mapping the heavens, but also connected astronomical observations to cultural and religious beliefs. One of the earliest and most significant achievements in Chinese astronomy was the creation of detailed star maps. These maps, also known as star charts, recorded the positions of stars and constellations, allowing astronomers to track celestial movements and predict future events. The Dunhuang Star Chart, dating back to Tang Dynasty, is one of the oldest surviving examples, showcasing the precision and dedication of Chinese astronomers. The significance of celestial observations in Chinese history cannot be overstated. These observations were meticulously recorded and used to interpret events on Earth. For example, the appearance of comets and the occurrence of supernovae were seen as omens, signaling significant changes or events. One famous example is the recording of the supernova SN 1054, which created the Crab Nebula. Ancient Chinese astronomers documented this event in detail, providing valuable historical data that continues to be studied by modern astronomers. Chinese astronomers also played a critical role in timekeeping. They developed various devices such as water clocks and the gnomon, a type of sundial to measure time accurately based on the sun's position. These advancements in timekeeping were essential for maintaining the calendar and scheduling important activities. As we set the stage for exploring the astronomical achievements of ancient China, it's clear that their contributions were vast and varied. From the development of star maps to the recording of celestial events and the creation of sophisticated calendar systems, Chinese astronomers demonstrated a deep connection to the heavens. Their work laid the foundation for future discoveries and highlighted the importance of aligning human activities with the natural and divine order. Continuing our exploration into the wonders of ancient Chinese astronomy, let's delve into one of their most remarkable achievements, the creation of the first star map. These maps, also known as star charts, were detailed records of positions of stars and constellations, and they played a crucial role in the development of astronomy. The ancient Chinese were meticulous observers of the night sky, and they realized early on that mapping the stars could help them better understand the cosmos. These star maps weren't just artistic representations. They were practical tools that allowed astronomers to track celestial movements and predict future events. Imagine the dedication it took to stand under the vast expanse of the night sky, night after night, charting the positions of countless stars. One of the earliest and most significant examples of these star maps is the Dunhuang Star Chart. This ancient manuscript, dating back to the Tang Dynasty, is a true testament to the precision and dedication of Chinese astronomers. The Dunhuang Star Chart is one of the oldest surviving star maps in the world, and it provides a fascinating glimpse into the astronomical knowledge of ancient China. The Dunhuang Star Chart was discovered in the Mogao Caves, also known as the Caves of Thousand Buddhas, located in the Dunhuang region of northwestern China. These caves were a major center of Buddhist worship and learning, and the star chart was found among a treasure trove of manuscripts that had been sealed in a hidden library for centuries. The chart itself is a detailed and accurate depiction of the night sky, featuring over 1,300 stars arranged into more than 250 constellations. The creation of these star maps had immense significance. For ancient Chinese astronomers, accurately recording documenting the positions of stars and constellations was essential for a variety of reasons. Firstly, it allowed them to develop more precise calendar systems. By tracking the movement of stars and constellations, they could predict the change in seasons, which was crucial for agricultural planning. Knowing when to plant and harvest crops could mean the difference between a bountiful harvest and a devastating famine. Secondly, star maps were used for navigation. By knowing the positions of key constellations, travelers and sailors could find their way across vast distances, whether on land or at sea. The stars provided a reliable guide, helping to ensure safe journeys and the successful completion of trade missions. Thirdly, star maps held significant cultural and spiritual importance. The ancient Chinese believed that the heavens reflected the earthly realm, and that celestial events could influence human affairs. By studying the stars, they sought to understand the will of the gods and ancestors, and to align their actions with the divine order. This connection between the cosmos and daily life is beautifully illustrated in the intricate star maps created by Chinese astronomers. In addition to the Dunhuang Star Chart, other notable examples include the star maps from the Tang and Song dynasties. These maps continued to build on the knowledge of earlier astronomers, refining the accuracy and detail of celestial charts. The work of these astronomers showcased their ability to observe the night sky with remarkable precision and to document their findings in ways that would endure for centuries. The development of star maps by ancient Chinese astronomers was a monumental achievement that not only advanced the field of astronomy, but also had profound implications for society. These maps were more than just scientific tools. They were a means of connecting with the divine, ensuring the well-being of the community and navigating the world. The dedication and skill of these early stargazers laid the foundation for future discoveries, inspiring astronomers across cultures and eras. Records of supernovae and comets reveal the incredible dedication and observational skills of Chinese astronomers. These celestial events weren't just spectacular sights in the night sky, but were carefully documented to provide valuable insights into the workings of the universe. Chinese astronomers were among the first to systematically record supernovae and comets, recognizing their importance in understanding celestial phenomena. Imagine standing under the vast expanse of the night sky, observing the sudden appearance of a new bright star or the long glowing tail of a comet. These events were seen as omens or messages from the heavens, and the Chinese took great care to document them in detail. One of the most famous recorded supernovae is SN 1054, observed in 1054. This supernova was so bright that it was visible in the daylight for several weeks and remained visible in the night sky for nearly 2 years. Ancient Chinese astronomers meticulously recorded this event, noting the position in the night sky, its brightness, and its duration. This supernova explosion eventually led to the formation of Crab Nebula, a beautiful and intricate remnant still studied by astronomers today. The records of SN 1054 provide a wealth of historical data that modern astronomers use to understand the life cycle of stars. By comparing ancient observations with current data, scientists can track the evolution of supernova remnants over centuries. The detailed documentation of SN 1054 by Chinese astronomers is a testament to their commitment to capturing these celestial events with precision. But the Chinese didn't just record supernovae. They also kept extensive records of comets. Comets were considered significant celestial visitors, often interpreted as harbingers of change or important events. The ancient Chinese developed a system to classify comets based on their appearance, duration, and movement. They noted details such as the length and direction of the comet's tail, the color and brightness of the comet, and any changes in its behavior over time. These comet records were systematic and thorough, providing a comprehensive view of each observed comet's characteristics. For example, the Chinese astronomers recorded the appearance of Halley's Comet in 240 BCE, one of the earliest known sightings of this famous comet. They meticulously noted its path across the sky and its visible features, creating a valuable historical record that aligns with modern observations of Halley's Comet. The precise recording of supernovae and comets by ancient Chinese astronomers wasn't just about capturing the beauty of the night sky. These records served a practical purpose, such as predicting the timing of agricultural activities, aligning religious ceremonies, and advising rulers on political decisions. By understanding the movements and appearances of these celestial phenomena, the Chinese sought to harmonize their lives with the rhythms of the cosmos. Their detailed and systematic observations provide a rich source of historical data that continues to inform and enhance modern astronomical research. The records of SN 1054, for example, offer a unique opportunity to study the long-term evolution of a supernova remnant, while the extensive comet records help scientists understand the behavior and characteristics of these icy wanderers. As we continue our journey through ancient Chinese astronomy, let's take a closer look at their remarkable achievements in developing sophisticated calendar systems and timekeeping devices. These advancements were essential for synchronizing agricultural activities, festivals, and governance, ensuring that society could function smoothly with the rhythms of the cosmos. The ancient Chinese placed great importance on aligning their daily lives with the movements of the heavens. They developed calendars that combined lunar and solar cycles, known as the lunisolar calendars, to accurately track the passage of time. This careful synchronization was crucial for planning agricultural activities, determining the dates of important festivals, and guiding governance decisions. The lunisolar calendar was a brilliant innovation that balanced the cycles of the moon and the sun. The lunar cycle, with its phases of new moon to full moon, takes approximately 29.5 days. A typical lunar year consisting of 12 lunar months added up to about 354 days, which is shorter than the solar year of approximately 365.25 days. To reconcile this difference, Chinese astronomers introduced an extra month, called an intercalary month, every few years. This process of intercalation ensured that the calendar stayed in sync with the solar year and the changing seasons. The lunisolar calendar was not only a practical tool for farming, but also played a significant role in Chinese culture and religion. Festivals and rituals were often tied to specific lunar phases or solar events, and an accurate calendar was essential for maintaining these traditions. For example, the famous Chinese New Year, which marks the beginning of the lunar year, is celebrated based on the lunar calendar. Other festivals, such as the Mid-Autumn Festival, are also tied to lunar phases, highlighting the deep connection between celestial observations and cultural practices. In addition to developing sophisticated calendar systems, ancient Chinese astronomers invented various timekeeping devices to measure time accurately. One of the earliest and most significant inventions was the gnomon, a simple yet effective sundial. The gnomon consisted of a vertical stick or a pillar that cast a shadow on a marked surface. By observing the position and length of the shadow throughout the day, astronomers could determine the time and track the movement of the sun across the sky. The gnomon was a vital tool for calibrating other timekeeping devices and for conducting astronomical observations. It helped astronomers measure the length of the solar day, determine the solstices and equinoxes, and establish the noon meridian. The gnomon's simplicity and accuracy made it an essential instrument in the early development of Chinese astronomy. Another significant timekeeping invention was the water clock. The ancient Chinese developed various designs of a water clock to measure the passage of time based on the steady flow of water. One common type was the clepsydra, which consisted of a vessel with a small hole at the bottom, allowing water to drip at a constant rate into another container. By measuring the amount of water collected over a specific period, the time could be determined. Water clocks were used for a variety of purposes, including regulating daily activities, scheduling official duties, and conducting astronomical observations. The accuracy of water clocks improved over time, with more complex designs incorporating gears and other mechanisms to enhance precision. The water clock's ability to measure time continuously, even at night or on cloudy days when the sun was not visible, made it an invaluable tool for ancient Chinese astronomers and scholars. The development of sophisticated calendar systems and timekeeping devices by ancient Chinese astronomers showcased their ingenuity and deep connection to the cosmos. These advancements were not just about measuring time, they were about harmonizing human activities with the natural world and the divine order. By accurately tracking the movement of the heavens, the Chinese ensured that their society could thrive and prosper in harmony with the celestial cycles. As we delve deeper into the achievements of ancient Chinese astronomy, it's essential to highlight the incredible contributions of notable astronomers like Heng and Shoujing. These brilliant minds not only advanced the field of astronomy, but also left a lasting legacy with their innovative inventions and reforms. Heng, born in 78 CE, was a true polymath. His interests span across astronomy, mathematics, engineering, and literature. One of his most famous inventions was the seismoscope, an early earthquake detector that demonstrated his deep understanding of natural phenomena. The seismoscope, invented around 132 CE, was a remarkable device shaped like a large bronze urn. It had 8 dragon heads positioned around the rim, each holding a bronze ball in its mouth. Below each dragon head was a toad figure with an open mouth. When an earthquake occurred, the internal mechanism of the seismoscope would detect the seismic waves and cause one of the dragon heads to release a ball into the corresponding toad's mouth. The direction of the released ball indicated the direction of the earthquake's epicenter. This ingenious invention provided early warnings of seismic activity and showcased Zang Heng's ability to translate his observations into practical applications. But Zang Heng's contributions didn't stop there. He also created a celestial globe, an intricate model of the night sky that helped astronomers astronomers visualized the positions and movements of celestial bodies. This globe was driven by a water-powered mechanism, allowing it to rotate and simulate the apparent motion of the stars and planets. The celestial globe was an essential tool for teaching and studying astronomy, demonstrating the harmonious order of the cosmos and interconnectedness of celestial phenomena. Moving forward to the 13th century, we meet another exceptional figure in Chinese astronomy, Shoujing. Born in 1231 during the Yuan dynasty, Shoujing was a renowned astronomer, engineer, and mathematician. His work significantly advanced the accuracy of astronomical observations and calendar systems. One of Shoujing's most notable achievements was his reforms to the Chinese calendar. The existing calendar systems at the time were becoming increasingly inaccurate due to the accumulated errors over the centuries. Shoujing was tasked with creating a new, more precise calendar. In 1280, he introduced the Shoujing calendar, which improved the calculation of the solar year and the lunar month. His reforms included more accurate measurements of Earth's orbit and the moon's cycles, ensuring that the calendar remained in sync with natural world. The Shoujing calendar was highly regarded for its precision and was used for several centuries. Shoujing also developed advanced astronomical instruments that furthered the study of the heavens. One of his most significant inventions was the simplified armillary sphere, a three-dimensional model representing the celestial sphere. This instrument allowed astronomers to measure the positions of stars and planets with greater accuracy. Shoujing's simplified design made it easier to construct and use, contributing to more precise observations and calculations. Another Shoujing's innovation was the gnomon, a device used to measure the angle of the sun's shadow and determine the time of the day. While the gnomon was not a new invention, Shoujing refined its design and improved its accuracy. His version of the gnomon was used to conduct detailed solar observations, which were essential for calibrating other astronomical instruments and refining calendar calculations. The contributions of Zang, Heng, and Shoujing highlight the ingenuity and dedication of Chinese astronomers. Their inventions and reforms had a profound impact on the field of astronomy, demonstrating practical applications of celestial observations in everyday life. Zang Heng's seismoscope and celestial globe showcased his ability to turn theoretical knowledge into functional tools, while Shoujing's calendar reform and advanced instruments ensured the continued accuracy and reliability of astronomical data. As we reflect on the achievements of these key figures, we see a legacy of innovation and precision that continues to inspire astronomers today. The work of Zang Heng and Shoujing laid the foundation for future discoveries, contributing to our understanding of the cosmos and our ability to navigate the complexities of natural world. The meticulous observations, innovative instruments, and sophisticated calendar systems developed by Chinese astronomers didn't just remain within the borders of China. They traveled far and wide, influencing the course of astronomical progress across the world. One of the key periods when Chinese astronomical knowledge was shared and expanded upon was during the Ming Dynasty. During this time, China experienced a flourishing of culture, science, and exploration. It was also a period of increased interactions with the Western world, especially through the efforts of Jesuit missionaries. These missionaries brought with them not only their religious teachings, but also their knowledge of European science and astronomy. The collaboration between Chinese astronomers and Jesuit missionaries during the Ming Dynasty was a remarkable example of the exchange of ideas that enriched both Eastern and Western astronomical traditions. Jesuit missionaries such as Matteo Ricci arrived in China with a deep appreciation for Chinese culture and a desire to share their scientific knowledge. They brought with them advanced European astronomical instruments and introduced new methods of observation and calculation. In return, the Jesuit missionaries were eager to learn from Chinese astronomers, who had centuries of accumulated knowledge and experience. This exchange of ideas led to fruitful collaboration that benefited both sides. Chinese astronomers gained access to new tools and techniques, while the Jesuits were able to incorporate Chinese observations and data into their own studies. One of the significant outcomes of this collaboration was the improvement of Chinese calendar systems. The existing Chinese calendar had accumulated errors over time, leading to discrepancies between the observed and predicted celestial events. The Jesuits, with their advanced knowledge of European astronomy, helped to correct these errors and refine the calendar. Their work, combined with the expertise of Chinese astronomers, resulted in more accurate and reliable calendars that better aligned with the natural cycles. Another notable achievement was the construction of advanced astronomical astronomical instruments that combined both Chinese and Western designs. The Jesuits introduced the telescope to China, which revolutionized the way celestial observations were conducted. Chinese astronomers quickly adopted this new technology, using it to enhance their observations of stars, planets, and other celestial phenomena. The collaboration also led to the creation of comprehensive astronomical texts that incorporated knowledge from both traditions. The Chongzhen Li Shu, an astronomical treatise compiled during the reign of the Chongzhen Emperor, is a prime example of this fusion of Eastern and Western astronomy. It included detailed observations, calculations, and descriptions of celestial events, reflecting the combined efforts of Chinese astronomers and Jesuit missionaries. The influence of Chinese astronomical achievements extended beyond the Ming dynasty. The knowledge exchanged during this period continued to spread and inspire astronomers around the world. Chinese star maps, records of supernovae and comets, and sophisticated calendar systems were studied and admired by scholars in neighboring cultures and later civilizations. The detailed documentation of celestial events provided valuable historical data that informed and enriched the work of astronomers for generations to come. The exchange of ideas between Chinese astronomers and Jesuit missionaries highlights the importance of cross-cultural collaboration in advancing scientific knowledge. It demonstrates how the blending of different perspectives and techniques can lead to significant advancements and a deeper understanding of the cosmos. This spirit of collaboration and shared curiosity is a testament to the universal human quest to explore and comprehend the wonders of the universe. Throughout the ages, ancient Chinese astronomers made remarkable strides in understanding the cosmos. Their meticulous observations and innovative approaches significantly shaped astronomy. The legacy of ancient Chinese astronomy is a testament to their dedication, curiosity, and profound connection to the cosmos. Their contributions continue to inspire and inform our understanding of the universe today. Thank you for watching episode 3 of the series. Hit the like button and subscribe to support the growth of our channel. Keep looking up.